I'm going to include it on your semester exam. So let's make sure we get what's going on.
We have to take it first.
It's unfortunate.
You should.
I should just, yep, say no. Actually, Mr. Hollis, we were in the parking lot together on prom night, and he brought me my very favorite food in the whole wide world, a little container of cherry tomatoes. It was like so sweet. It's like, oh, thank you, Mr. Noel. All right, so I'm going to break this up into its partial fractions. Step 1, factor your denominator. Now, I am never going to give you one of these problems that doesn't factor, okay, or the denominator. We're only interested in factoring the denominator. So I have factored my denominator. You okay with that? Now, we're going to think of this thing right here as the sum of two fractions, one of whose denominator is x minus 2, and the other one whose denominator is x minus 1. Now, if you think about this, that should make sense to you, because if you add these two fractions together, if I said let's add these fractions, wouldn't you get a common denominator? And wouldn't that common denominator be this? So we are simply finding the numerators, and you can call them x and y, I'll call them a and b, it doesn't matter. You're finding the numerators that would make it so if you added these two together, this is what you would get. Okay? So there's the setup. Everybody okay with that? Now, I'm going to solve this little equation. So I am going to multiply everything by x minus 2, x minus 1. That's how I solve equations that have fractions in them. I clear the fractions out, because what happens here, if I multiply this fraction by this, what happens? I am just left with 4x minus 5. Now, what's going to happen here? Well, these are going to cancel, and what am I going to be left with? ax minus a plus, okay, what's going to happen here? bx minus 2b. You with me? Now, you're thinking, ooh, boy, that doesn't look very good. Let's think about this for a minute. Doesn't it make sense to you that this has to be the sum of this and this? Doesn't that make sense? That the x's on the left would have to equal the x's on the right? Doesn't that make sense? So see if you can come up with a couple systems, or a couple equations that come from that.
I got the picture. So that's a nice pair right there.
I want too hard. You just made my hand go wet. Oh, yeah. Dude, I just didn't do it.
You didn't do it?
Dude, I knew that. You got freaking cold.
What is
How are you? How are you grading? How are you grading?
I have no idea.
You just go to
What's not due today?
We're talking about ours.
Those are due today.
Awesome. I need a highlight barrier.
Love an extra highlighter.
He said he'd like them today.
Okay, you say yeah.
Did you come up with an equation?
See, that sounds a lot better.
Did you come up with 4 has to equal a plus b? Now, pay attention, this is not hard. X's on this side have to equal X's on that side. So if I combine these two, A and B, they have to add up to give me 4. A and B have to add up to give me 4. Now what has to add up to give me -5? negative A minus 2B has to add up to give me negative 5. In other words, the x's on the left match the x's on the right, and the non-x's, plain numbers, on the left have to add up to the plain numbers on the right. Look what I've got there. Is that solvable?
Yeah.
Yeah. In fact, I can just add those together, and it says negative 1 equals negative b, so b equals 1. And if b equals 1, then a would have to be 3. And so your job was to find the two little fractions that add up to this, and you have now found them. The two little fractions, 4x minus 5 over x squared minus 3x plus 2, is the sum, I need to write this where there's room to write it, 4x minus 5 over 3x squared minus 3x plus 2 has to equal a, which was, what was a? 3 over x minus 2 plus 1 over x minus 1. A over x minus 2 is our original setup. So 3 over x minus 2 plus 1 over x minus 1. There's the partial fraction decomposition. These two little fractions add up to this. That's pretty easy, isn't it? Yeah. All right, let's try this side. There's another one on the page. Let's try it. So what do we do to get started? Who remembers what we do to get started? We factor the denominator, all right? So what are going to be the two factors of this denominator?
It's 14.
Oh, thank you. So what will be the two factors? X plus 3, x minus 2? So there are the two individual denominators that would add up to the big denominator, or the big, denominator, right? So I don't know, I'll call this A and I'll call this B. Now what? I'm going to multiply through to clear the fractions. Some of you are going to do that in your head, and that's fine. I choose to write it down because I don't want to make a careless mistake like in a distribution or something. So here we go. What does that leave me with when I clear the fraction? What's left on this side?
2x minus 14.
Just 2x minus 14. Because all that cancels. Here I'm going to be left with what?
Ax minus 2.
Minus 2a plus bx plus 3b. Now what? This is the crucial step. It's really easy. Do not make it hard.
2x equals
X
A.
plus B.
2 has to equal a plus b. And negative 14 has to equal negative 2a plus 3b. That's why this lesson is in this chapter, because now we have a system to solve, right? And you can solve this system any way you want. Substitution, elimination, Kramer's rule, inverse method on your calculator, RREF on your calculator. You can solve this any way you want. They're always easy to do the substitution and elimination now, because they always come out and have this equation right here. So I'll just multiply the top one by 2. And negative 10 equals 5b, so b equals negative 2. And if b is negative 2, what's a?
Four.
4. So then we write our answer. We have found the partial fractions now. What are they? Well, 4 over x plus 3. Remember, a was 4, and the way I set it up, I have a over x plus 3. So it's going to be 4 over x plus 3 plus negative 2 over x minus 2 equals 2x minus 14 over x squared plus x minus 6. These are called the partial fractions. They're the little fractions that add up to the original problem. Got it? Okay. While we're on this sheet, let's go ahead and just do the rest of this sheet to make sure. In the little box, I wrote find the area of the triangle. Let's look at this for a minute. We actually talked about it a long time ago. Let's talk about it again. I mean, months ago, or weeks ago, maybe not months, but weeks ago. We have a triangle out there, and I've given the vertices of the triangle. I'm going to find the area. You have lots of ways of doing that, but one way to find the area is to use the determinant, believe it or not. Remember, the determinant looks like this. How do we evaluate that? A little bit of review here. How do we evaluate this determinant? 4 minus 6. So the answer would be negative 2. Here's what I want you to do to find the area of the triangle. I want you to build a determinant. And the determinant you build is simply going to be 2 vectors that represent the sides of the triangle. Now, I have automatically just gone with AC and AB. You could go with other vectors. It doesn't matter. But I'm going to go ahead and go with AC and AB. So more review. How do we find, or what would be the coordinates of the vector from A to C? From A to C. What are those coordinates? Negative 2, 3. Now, for those of you that forgot, it's common sense. You're going from 1 to negative 1. How many steps is that? Negative 2. You're going from negative 2 to 1. How many steps is that? 3. Right? Now, what about this vector, AB? What are his coordinates? 2, 6. Now, put those into a determinant. So just write them down. The order you write them doesn't matter. I mean, when I say that, I mean, I don't care which one's on top. So I write negative 2, 3, and 2, 6. Now I'm going to evaluate that determinant. What is the value of that determinant? Negative 12 minus 6. So that's negative 18. Take half of that. This is a triangle. When we find the area of a triangle, no matter what formula we use, it involves a half. Remember, 1/2 base times height? 1/2 side, side, sine. Even Hero's formula that uses the semi-perimeter is half the perimeter. So we're going to take half of that. We would get negative 9, and then make it positive. Take the absolute value of it. So the area of this triangle is 9. You can find the area of a triangle using the determinant by simply building 2 vectors representing the sides of the triangle, and any 2 vectors will work. Any 2. Put them in a determinant, evaluate it, cut it in half, and if it's negative, go ahead and make it positive because it represents area. Okay? So for those of you that were thinking back when we talked about determinants last week, what do we use this for? We use them to find inverses, right? We use them in Kramer's rule, and now we have another use. We can use them actually to find the area of a triangle. I can tell you're all super excited by that. Okay, speaking of Kramer's rule, let's review this. Because we will have a test question that says, solve using Kramer's rule. Okay, who remembers anything about Kramer's rule?
No clue. 2,
No
3,
clue.
we got the 1 and the -2.
Okay,
We
so
also have
first,
the
yes, Mr. Harvey, you're right. First, we want to build a determinant. We just talked about that in terms of the area. Build a determinant that has just the coefficients. Okay, what is the value of that determinant?
-4, -7.
-4 minus 3, -7. Perfect. Now what? Anybody remember? Marin?
You put -7 as the denominator.
Remember, we are solving for x and y, and -7 will be the denominator of both. The coefficient determinant becomes the denominator of x and y. Anybody remember how to find the numerators?
Put -7.
They are determinants.
2 and 3 and then replace them.
So we take these two numbers right here, and if we are solving for x, we put them right here, because these are the x numbers right here. So we take those and put them here. So we would have 7, 9, and then the y's stay the same. And then we have 2, 3, 7, 9. Okay? Now, let's evaluate those determinants. So what do we get on top of there? -14 minus 9, which is negative. So x comes out to be 23/7. And what's y? 3/7. So we write our answer as 23/7 3/7 because that reminds us that these are lines, and when we're solving the system, we are looking for where they cross, and they cross in a point, and that point is right there. Everybody okay with that? All right, let's turn the page over. Now this we have done on the calculator. We have not done it by hand. So we are going to do it by hand now, but first I want to do it on the calculator again to make sure we remember how. So can somebody remember, we're going to do this on the calculator first, then we're going to do it by hand. Can somebody remember how we do this on the calculator? What buttons we press or what we need to do to get ready to do this? Using the inverse method now. What? I need, well, I'm going to go into second matrix, but first, what am I going to put in there? I need to recognize, if I'm going to use the inverse method, I need two matrices. Does anybody remember what the two matrices are that I'm going to use when I do the inverse method? The coefficient matrix, which is 1, 2, 3, -1, and the constants. Now, the reason that I need those, remember, I can take this system and write it as a matrix equation. This is a single equation that represents this system. Here are the coefficients, here are the variables, here are the constants. I'm going to multiply both sides by the inverse so that these will cancel and leave me with my answer. So what do I multiply by? The inverse. So our answer is going to be the inverse of A, the inverse of the coefficients, times B. I wish you guys could see yourselves right now. I know it's hard. I know it is. I'm just gonna keep blabbing. I hope you're paying attention. A inverse times B, that's what I'm gonna type in on the calculator. So I need to enter, my Harvey's not even pretending, his eyes are just shut. He's just sitting there with his eyes shut.
These are not talking again.
All right, so A inverse times B. So I'm gonna put in matrix A. So as the lady said, I go to second matrix, and then remember, if I'm putting a matrix in, what do I press next? Or where do I go? Once I go to second matrix, what do I need to do? Go over to edit?
Yeah, edit.
Yeah.
I'm on board now, I got you.
And this matrix is 2 by 2. So then I put in the numbers. And after I put the last number in, and I press enter, then I quit, right?
Mm-hmm.
Then I go back in, and now I'm gonna put this matrix in. So I gotta click back over to edit, but now I gotta go down to B. What are the dimensions of this matrix? 2 by 1.
2 by 1.
So I put in 8 and 3. And then second quit again. So I have entered matrix A and matrix B, and they're in my calculator now.
Mm-hmm.
The answer comes from multiplying, if you're using the inverse method, which we are, the answer comes by taking the inverse of A times B. So I will, on my calculator, go back into second matrix and just press enter. That's how I get A. Then I'll press my inverse button, the button that has this on it, times second matrix, click down to B, enter, and the answer works out to be, did you get 2, 3? And that tells me that the answer, or the X value is 2 and the Y value is 3. Now, on your test, you'll be doing an inverse method problem. The system will be bigger than this for the one on the calculator, but the process is exactly the same. The matrices will be bigger, but the process is identical. Tom?
When is this test?
Friday. Thursday or Friday.
Okay.
We really only have one more thing to even talk about. We're just reviewing and kind of. Well, it could be, we might be ready Thursday, but we might not be ready till Friday. Okay, now, let's do this problem by hand. Remember, this is how we get the answer. Do not forget that. On the calculator, you just press those buttons. We are going to do this. We are going to do this now by hand. Okay? So we know what matrix A is. We're going to find its inverse. Okay, this is review. How do we find the inverse by hand? Anybody remember? Okay, we're going to do some changing here. So, oh, this one's tricky. These two are flipping spots. So the -1 is coming up here and the 1 is going down there. They are actually physically switching. What's happening to these two? The signs are changing. That's not all, though. There's another piece to this. Anybody remember what that is? You got to do 1 over the determinant, folks. Don't forget that. You've got to multiply that by 1 over the determinant. And what's our determinant? -1 minus 6, -7. So your inverse is 1/7, 2/7, 3/7, -1/7. Everybody okay with that? Now, How did we say we were gonna get our answer? Whether you're doing it by hand or with the calculator, this is how you get the answer. So we have to, if we're doing it by hand, we have to take the inverse of A, which you have already found. And we are gonna multiply it times matrix B, and that should give us our answer. Now, let's talk about how we multiply. Again, we'll review. What are the dimensions of this matrix? 2 by 2. What are the dimensions of this matrix? 2 by 1. Can they be multiplied? Thank goodness, right? And the answer will be a 2 by 1 matrix. 2 rows, 1 column. This spot is the first row, first column. So we need to multiply the first row times the first column. Remember how to do that? First times first, second times second. Now they have the same denominator, so just forget that for a second. This would be 8 and 6, right? 8 and 6. What's 8 and 6? 14 divided by 7, 2. Now, how do we find this spot? Second row, first column. So that's 24 minus 3. 8 times 3, that's 24 minus 3. 21 divided by 7, 3. There's your answer, the same answer we got, of course, when we did it on the calculator. We just did that work by hand. No matter whether you're doing it by hand or with the calculator, this is what you need to do when you're finding the answer with the inverse method. Okay? We'll practice another one, but let's finish this sheet first. All right, how about the next part there? Can you do A? Oh, boys and girls. Can we add A and B? Yeah, because what's the rule for addition? Same dimensions. They have the same dimensions, so we can add. So what do we have? What do we put here? 2, how about here? 0, how about here? 4, and here. Everybody got that? That's easy. How about 2b? I bet you can do that one too. What's 2b mean to do? Take everything in b and times it by 2. So 2, negative 4, 14, 10. Okay with that? And what do we call the number 2 in that problem? A scalar. Yeah. All right, let's look at C. That means multiply A times C. Not possible. Because what are the dimensions of A? 2 by 2. What are the dimensions of B? You cannot multiply a 2 by 2 and a 3 by 3 because these numbers don't match, right? And they have to. So that's not possible. Determinant of C. Okay, this is review. Remember, the vertical bars mean determinant. So I'm going to go ahead and use my vertical bars. Who remembers this? First 2 columns. These are the first 2. This is what gets copied, just the first 2. Then we start here, and we multiply those numbers together, and what do we get? 0. And then here, and here. And we total those up, boys and girls. You total them up. You are not done. Now you go this way. So that is 0. That is, and that is. Oh my goodness gracious. What do I do with this 4 and this 4? Subtract them. So the value of this determinant is 0. Okay, we got some review there. Some things starting to come back a little bit. Okay, I need you to look then, if you would. In your book, on page 7.4, section 7.4, which is page. So I tell you what, we're gonna do one more problem and then I'm gonna stop and let you rest. Because I can tell you're exhausted. So we're gonna do one more problem. This is the last thing we need to do in this little chapter. And the good news is, we've already done it. It was a long time ago, but we've already done this. We are going to sketch this. Tell me anything you can remember, think of, anything to get us started on sketching this. We're going to draw a picture of this thing.
X cannot be 3.
Andrew, the denominator cannot be 0. What does that mean graphically?
X can't be 3.
X can't be 3, which graphically is represented how?
With a hole.
Not as a whole,
Alright.
as a vertical asymptote. Could we have holes? Yes. Not in this problem though. Does anybody remember how we get holes? Well, you don't have to have an x squared. You usually
When you
do.
factor something out.
You have to be able to factor and cancel. If you cannot cancel, you have no holes. Does anything cancel in this problem? No. So therefore there are no holes. Now tomorrow we'll look at a harder problem and it'll have some holes. But this one, no holes. There is a vertical asymptote though at x equals 3. If you have forgotten, remember, vertical asymptotes are where the denominator is 0. There cannot be. When you say to me x can't be 3, that means I have a vertical asymptote. Okay, anybody remember anything else about this picture? There's a horizontal asymptote. Do you know where it is? At 1. Why, Redor, is the horizontal asymptote at 1? Yeah, because the limit as x approaches infinity of this problem is 1. Right there, the limit is 1. Horizontal asymptotes come from the limit. Will every problem have a horizontal asymptote? No. If you had an x squared over an x, you wouldn't have a limit, right? It would be a divergent. All right, anybody remember anything else? There are a couple points we should probably plot. Tom?
Does y equal negative 2/3?
The y-intercept would be negative 2/3. And how do we get a y-intercept? Plug 0 in for x. The x-intercept is negative 2, and how do we get that? Plug 0 in for y. And when you plug 0 in for y, does everybody understand why x would equal negative 2? Now, the important stuff is now in the picture. Do you remember what I advised you before? If the important stuff isn't enough, what do? Plot more points. But if the important stuff is enough, which I think it might be in this problem, you can go ahead and connect the dots. Does that look familiar? There's another piece to it though, isn't there? Right up here. Now again, if you are all uncomfortable with that, plot some points. Keeping in mind though, that these are the only two places you can cross the axis. There's no other places you can cross an axis in this picture. But we'll do more of that. Tonight's homework is a review partial fractions problem. So you can just jump in and do that. So we'll review a graph a little bit more tomorrow. So you have this time to do what you need to